Happy Wednesday, everybody. I hope you're all doing well out there. We have finished just about everything we need to do with the quadratic function. So we're going to move on now to some geometry topics and go back to something that we've done earlier in the year, which is the Pythagorean theorem. And we're going to use the Pythagorean theorem to find distance on the coordinate plane. So what things begin with today with finding distance on the coordinate plane is we've got three different types of distance on the coordinate plane. We've got horizontal distance, we've got vertical distance, and we've got diagonal distance. So like you see here in our example number one, and points A and B in this first example are horizontal. So whenever we have a horizontal distance, we just start at one point and we count the units from point to point. So we have 1, 2, 3, 4, 5, 6. So my distance between points A and B is going to be 6 units. And we always assume it's 1 unit unless we're told otherwise. All right, so that's my horizontal distance. If I look at the next example right underneath it at points A and B, what I have here is a vertical line. So I also have vertical distance. So my vertical distance from A to B is I just started A and count 1, 2, and that's going to be 2 units. Okay? So I have both horizontal distance and vertical distance. So I'm going to take what I know about horizontal distance and vertical distance and use it along with the Pythagorean theorem to find a diagonal distance on the coordinate plane. So if I look here at the next example that we have, okay, the next example gives me 2 points on the coordinate plane. So I have point A, which is at, it looks like 8, 2. And then I have point B, which is at 2, 4. And if I look at these 2 points from point A to point B, I have a diagonal. So my distance is diagonal. So the way I'm going to find diagonal distance is by using the Pythagorean theorem, which we know the Pythagorean theorem is a squared plus b squared equals c squared. And the Pythagorean theorem also only applies to right triangles. So what I'm going to do to solve for my distance from A to B is I'm going to draw a right triangle. So I simply start at one of the points and extend a line from that point, and then I go to my other point and I extend a line, and I look for that point of intersection. And where I have my point of intersection, right over here, I have a right triangle. And now that I have a right triangle, I can label my sides, side A, side B, and side C. So I have a right triangle. C is always my hypotenuse, and the hypotenuse is always across from the right angle. So now all I need to do is find my vertical distance and my horizontal distance, and then I can solve for the diagonal distance. So let's start with A, which is 1, 2. So that's going to be 2 squared plus my horizontal distance in B is 1, 2, 3, 4, 5, 6. All right, so 2 squared plus 6 squared is going to equal c squared. So 2 squared means 2 times 2, so 2 times 2 is 4. 6 squared means 6 times 6, so 6 times 6 is 36. And all that's going to equal c squared. So 4 plus 36 is 40, and that equals c squared. And then I just find the square root of 40 and the square root of c squared. And when I do that, remember that the square root function is the opposite of the exponents. So the square root of 40 rounded to the 10th is going to be c equals 6.3. which means my distance for C is 6.3. So my diagonal distance between point A and point B is going to be 6.3. All right, so let's look at another example. All right, I have points A and B on this graph. So point A is the ordered pair -5, -4. And then point B is the ordered pair -2, -1. Okay, so we're going to connect these 2 points. And I see here that they are a diagonal distance. So what I'm going to use, like we've already said, is my Pythagorean theorem to solve for the diagonal distance, which is the a squared plus b squared equals c squared. All right, so now I can go ahead and draw my right triangle. So if I start at point A and I extend my line this way, and if I start at point B and extend my line this way, where the 2 lines intersect, they form a right angle. So since I formed that right angle, I now have a right triangle. So I can go ahead and label my sides A, B, and C. So now all I need to do is find my vertical distance and my horizontal distance, and then I can solve for the diagonal distance. So A is 1, 1, 2, 3. So that's going to give me 3 squared. And then B is 1, 2, 3 as well. So that's going to be 3 squared again. And all that's going to equal c squared. So 3 squared means 3 times 3, so that's going to be 9 plus 9. And all that's going to equal c squared. So 9 plus 9 is 18, which equals c squared. So what I do now is find the square root of 18. And those are going to cancel out because the inverse of an exponent is the square root function. So on my calculator, I type the square root of 18, and I get c equals 4.2 rounded to the 10th. So that means my distance between A and B is 4.2 units. All right, then this will be, this one here will serve as our last one. And then you can go ahead and do the practice work after this. So here it is. I've got point A again, which is at -1, -4. And then I have B, which is at 4, 2. So again, if I'm looking for my distance between A and B, again, this is a diagonal distance. So I need to construct a right triangle. And when I construct my right triangle, I'm going to use my a squared plus b squared equals c squared Pythagorean theorem to solve for that diagonal distance. So I extend a line this way, and I extend a line this way. And so when my 2 lines intersect, I have a right angle, which means I have a right triangle. So we'll go ahead and label our sides. Here's A, here's B, and here's C, because C is the hypotenuse, and it's always across from the right angle, and that happens to be the side we're looking for. So then, let's count our distance. So my horizontal distance A is 1, 2, 3, 4, 5. So that's going to give me 5 squared. And then my vertical distance for B is 1, 2, 3, 4, 5, 6. So that gives you the 6 squared. And all of that equals to c squared. So 5 squared, 5 times 5 is 25. Plus 6 squared, 6 times 6 is 36. And all that's going to equal c squared. So 25 plus 36 gives me 61. And that equals c squared. So then I find the square root of both sides. And then these two are going to cancel out. So the square root then of 61 is going to be, rounded to the 10th, is 7.8. So that means my distance for side C is 7.8. All right, everybody, that's all there is to it. So go ahead and go to the assignment now, and when you're finished, make sure you upload a photo or scan to Google Classroom. Show me your work, show me steps, show me success. And if you have any questions, come and see me on Google Meet. Have a great day.